Okay, so this is for the Unit 6 retest, and I'm going to tackle number C next. So this is an improper integral because remember, if you look at this denominator, if I plug in 0, that's a problem. That's what makes this an improper integral. So I can handle it. The way I get around that is by taking the limit as a approaches that problem point. Okay, so for this one, I'm going to write the limit as a approaches 0, because that's the problem point. And I'm going to change my integral to that from -1 to a. And instead of writing this as 1 over x squared, I'm going to bring that exponent up and make it negative so that it's like this. All right, so that's not so bad. Now I can integrate this. So to integrate this, you add 1 to the exponent, divide by that number. So we could say that that equals, I didn't take the limit yet, so you still rewrite the word limit. And I add 1 to the exponent, so -2 plus 1 is -1 over -1, and I'm going to evaluate that from 1 to a. And then from there, I'm like, okay, I don't like the way that this looks. That's hard for me to plug in, so I'm going to rewrite it. Again, I didn't take the limit, so you just bring that limit guy down. And I'm going to rewrite this, so this goes into the denominator, right? So that's going to be x to the first, or just x. And then it's a 1 is still there. I'm going to pop that negative up top, so it ends up like this. And I still didn't evaluate it, so that's still going from 1 to a there. And now I'm going to use my fundamental theorem of calculus. I'm not taking the limit yet, so that guy just gets recopied again. Oh, make sure I don't go off the page there. And so when I plug in an a, you get -1 over a minus, right, fundamental theorem of calculus. Plug in a 1, x to the first is just 1, so it's minus a -1. So minus a negative turns to a plus 1 there. Now I'm going to take the limit. So only once I plug this in can I drop that limit. So when I plug in a 0 there, that's a problem, right? So this divided by 0 plus 1, that's going to infinity. So dividing by 0 is not good. When would I get an answer of 0 there? If it was divided by infinity, right? A number divided by infinity is 0. A number divided by 0, that's bad. So what does that tell you about this entire thing? It's trashed. The whole thing diverges. Once you get one piece that goes to something super duper, think about it, is we're getting really, really close to 0. If we're dividing by something like really tiny, you're headed to infinity. So this is like infinity plus 1. So you could say that that whole thing diverges. Okay. All right, let's tackle another one. I'm just going to skip this one, the next one, and I'm going to go to E, just because D took up a lot of room, and so we'll just go to E. All right, so for E then, very similar. We have an improper integral because this time there's an infinity. So whenever you see an infinity, that lets you know that it's improper by definition. So to tackle this one, I'm going to take the limit as a approaches infinity, because infinity is the problem point. And we're going to integrate it then from 0 to a. And that's going to be e to the -x dx. Okay? All right, so integrating e to the -x. Well, the integration of e to the x is just e to the x. But when you're integrating it, you could technically, if you needed to off to the side, do a u substitution on this. But I'm hoping that most of you have kind of recognized the pattern by now, that the integration of e to the x is you recopy it, and then it's out front, you have to put 1 over the derivative out there. Okay, 1 over the derivative. Well, 1 over -1 is still -1. So when I write this, I'm going to write this as, I guess I'll go this way, the limit as a approaches infinity, because I'm integrating, I'm not taking the limit yet. So the integration of that is -e to the -x. And if you're not sure, how can you always check? This? Take the derivative. The derivative of this, you'd recopy it, multiplied by the derivative of this, which is 1. So that would go away. That would take me back to there. So that's how you know you did it right. Okay? And again, if you need to do a u sub off to the side, you can. But hopefully at this point, you've kind of mastered that. Okay. So once we get to there, now I'm going to use my fundamental theorem of calculus. So I still haven't taken the limit. The limit just keeps coming down. I get so sick of writing that limit. But all right. when you plug in here, you plug in an a, so you get negative e to the negative a minus. Then when you plug in again, you get minus e to the 0. Okay. So if you need to kind of rewrite that again, that's the limit as a approaches infinity. I'm going to rewrite that because negative exponents kind of confuse me. So I'm going to rewrite this as negative 1 over e to the a plus anything to the 0 is 1. That looks like something I could take the limit of. Okay, so now when I plug in an infinity here, and this was the problem in the test, people did this, and then they were like, oh, e to the infinity is infinity, because you were too cool for your scratch work. Well, I'm telling you, you're not too cool. Rewrite it, because now when you go to plug in this infinity, it's easier to see that e to the infinity is infinity. So you have negative 1 over infinity. Well, what happens when you divide by infinity? It's 0 plus 1. So now you can see that this indeed converges, right? That equals 1. So this converges. So the last example diverged because my answer was an infinity. This one, it converges because here I was dividing by infinity, so I got 0. Make sure you can tell the difference between those two things. Okay? All right, so here we are evaluating limits. And if this was the old way back in September, right, you would have, well, the first thing you always do is plug in. Well, here's the problem when I plug in a 1 here. 1 plus 3 minus 4 is 0 over 0, right? So first, you always try to plug in. You get 0 over 0, and you're like, oh, that's so sad. Except for now that you know L'Hopital's, that doesn't make you that sad anymore. So I would do this by L'Hopital's. Another way you could do it is by factoring. So if you wanted to factor and then cancel, that's what you would have done in the very beginning of the school year. That's still a valid method. But, you know, I just like L'Hopital's. So I'm going to go ahead and use L'Hopital's here. And L'Hopital says that the limit as x approaches 1, I can take the derivative of the numerator. So the derivative up there is going to be 2x plus 3 over 1. And now when you plug in 1 to that, 2 plus 3 is 5 over 1 is 5. You just get an answer of 5 there. So that's perfect. All right, very similar with this one. Again, you always try to plug in first. So when you go to plug in here, you get negative 3 plus 3 over negative 3 squared is 9 plus 9, and you get 0 divided by 18. This is not an indeterminate form. 0 divided by 18 equals 0. You're done. Don't get drunk on L'Hopital's and try to use L'Hopital's where you can't. You can only use L'Hopital's when it's an indeterminate form. That is not indeterminate. It's 0 divided by a number. Indeterminate form is 0 over 0, infinity over infinity, but not 0 divided by a number. Okay, so there we go on that one. All right, the next candidate we have up for grabs is part C here. Again, you plug in infinity and you're like, uh-oh, infinity over infinity. That, my friends, is an indeterminate form, which makes it a candidate for L'Hopital's. So this is an example where, like, you wouldn't have been able to do this one in September. You could have done this one in September using factoring, right? But this one you can't do. So you have to know L'Hopital's to do this one, I'm pretty sure. There might be some other weird way, but... All right, so the limit as x approaches infinity. Notice when you only use L'Hopital's when you're doing limits. Limits, L'Hopital's, that's the connection there. And the derivative, L'Hopital's by definition says, if you have an indeterminate form, that it is equivalent to the limit as x approaches whatever it's approaching originally of the derivative divided by the derivative. So the derivative of e to the x is e to the x, and the derivative of x squared is 2x. And now you're going to plug infinity into there, and you get infinity over infinity again. Wow, wow, wow. Well, the cool thing about L'Hopital's is he's like the gift that keeps on giving. You just L'Hopital it again. Yes, it's like an infomercial. But wait, there's more. So when you L'Hopital one more time, the derivative of e to the x is still e to the x. The derivative of 2x is 2. That'll do it. Because now when I plug in, I get infinity over 2, which is infinity. Okay, so you could say that, you know, the limit does not exist, or the limit is, it's headed towards infinity. Okay, so we've got that one there. All right, so the next question says a solid, it has a circle there, and we're trying to find cross sections parallel to the y-axis that are equilateral triangles and find the volume. So I might sketch a circle here to start with. Okay, so you've got a circle. This circle is centered at the origin with an R value of 9, or I'm sorry, an R value of 3. And so the first thing you might want to do is solve this. Now, because we're going to the y-axis, you want to solve that equation up here for x, aka to get x by itself here, you'd have to subtract y squared and then take the square root. So you've got x equals the square root. You'd have 9 minus y squared there. Now keep in mind when you take the square root, it's plus and minus, so the positive half is there. The negative part is down there. So you've got that. So the area that you need to figure out, it tells you that it's an equilateral triangle. So the area with respect to y this time, okay, don't forget the area of an equilateral triangle. There was that formula. It was a radical 3 over 4 side squared. All right, well, here's the deal. The side, if I was to drop an equilateral triangle in there, it's going to be this minus that, aka the positive square root minus the negative square root. Minus a negative turns to a plus. So essentially what's going to happen is you are going to have square root of 3 over 4, right? And then it's this thing plus itself. So it's going to be 2 of those. And if you need to write that out, you can. But it's going to be 2 of those. And don't forget this squared, so this thing has to be squared. And this is where a lot of the wheels fall off for people. When they go to square this, guys, this squared goes to the 2 and the square root. So when you go to clean it up, it's going to be it'll be 4 times 9 minus y squared like this. This 4 and that 4 kill each other, and you're just left with radical 3 times 9 minus y squared. Okay? What do you do with that? That is what you're going to go and integrate into the volume formula. So your volume, again, with cross sections, there's no pi as long as your shape that they give you isn't a semicircle or something with a circle. My bounds of integration, it goes back to this was 9, so that means your radius was 3. So this is actually, your picture goes from negative 3 to 3. And you're going to have this, and you just drop that in there, dy. And then you would go through and integrate this. I would actually take this radical 3 out, okay? If you factor that radical 3 out, run out of space, but if you factor that radical 3 out, you should end up with 36 radical 3. And this very well may be a setup question on the retest because you don't have your calculator. So, knowing that setup would be good. All right, quickly, the arc length. Remember, there is a formula for arc length that you need to know. So, for arc length, they're going to give you this, and they'll give you the bounds of integration. So this is where you need to take dy dx. All right, the derivative of y with respect to x, that's easy. You just take the derivative there. It gives you 3 minus 3x squared. And then you need to know what that thing is squared. So this thing squared is that squared. And again, if it's a setup problem, you'll be good there. So the formula for the arc length, which remember we use S to represent, it's going to be the integration. They'll give you the bounds, so it'll be 1 to 3, and it's the square root. A lot of people forgot to do the square root on the last test. So it'll be the square root of 1 plus dy dx squared. So I'm just going to write it in there. And so if those numbers were nicer, you'd be able to figure it out, but that one's not really nice. And if this was a calculator question, obviously you could put that right into your calculator. But again, your retest is not a calculator one, so you would just have to do the setup there if it was kind of nasty like this. Okay, so hopefully that helps.